Good morning, my dear students. In today's class, we'll discuss the simple pendulum and the compound pendulum and some related problems on the string springs here. Hmm. So let me start the class. So first we'll discuss with the basic pendulum. So here, the pendulum means it's going to oscillate. This will be the mean position. This will be the mean position. So it will be like this will be the right extreme. So I'll release it. So it's going to oscillate. Then again, so like this it will be oscillating. That one, this will become, what is one oscillation? Time taken to move from one extreme to mean, then left extreme, again back to the mean, again back to the extreme. This will become one oscillation. So like that it will be oscillating here. So now we are going to calculate the time period of pendulum. The this round color one will become a bob. This will have a mass m, bob of mass m. This will be light string. Okay, now if I release it, it will come to the these various positions. Okay, let's discuss some expression for time period of pendulum. That one. So the weight mg will act, string will be taut, tension will be set up here. Let this be theta. Then torque set up about point of suspension. That should be equal to, this distance is what, how much? L sine theta. So torque about point of suspension should be equal to mg L sine theta. This torque should be equal to I naught alpha. How is the angular displacement given? In this direction, whereas the alpha is in this direction. That's why this negative sign. So mg L sine theta. Moment of inertia ml square into alpha. And this is the light string. The string will be light. So therefore this alpha will become GL G minus G by L sine theta. No, this is not SHM. When theta very small means around 18 degrees. Roughly, there is no particular boundary. Theta should be less than for SHM. Not perfect, most of the books. Anyway, theta between 0 and 18 degrees, we can treat that to be an SHM. Few radians it is. Pi radian 180 degrees, pi radian 180 degrees. So approximately you can go for 3.14. No, 1 radian will come around 60. So very small, this one. So in terms of theta, it will be around 18 degrees is what we are taking. Some books they meant even for 15. So I'm just taking it to be around 18. Then the sine theta will become, comparing with angular SHM, omega equal to G by L. So time period is given by 2 pi L by G. So this is the expression for time period of pendulum. What is the time period? Time taken to complete one oscillation. Again, here also we can define the similar thing. Theta equal to theta naught sine omega t. What is this sine omega t? Omega is given by this one. Omega, will write it here. What is theta naught? Angular displacement given to the system. So theta equal to 0 degree, we define this line, white color. Theta naught, maximum angular displacement. What do you mean by this? At you are giving some angular spin for it. Some omega naught you are giving it, and because of that, the maximum angular displacement it can have is equal to theta naught. There's an angular amplitude. What is theta naught? You should call maximum angular displacement or angular amplitude. If you define t equal to 0, this particular point, it will be like this. If this is the mean position, something the angular velocity you are giving in this direction. If you release from right extreme, if you release from right extreme, okay. If the bob released when to write this equation when bob released from right extreme. When bob is okay, you start counting time when the bob is at mean position, then the equation should be of like this. Okay, some math based questions can be asked in exam. All possibilities there, that's why I'm just trying to stress. This will have a phase angle of 0, pi by 2, pi, 3 pi by 2, and 2 pi. Similar to like yesterday's what we discussed for spring block system, the same condition is applicable for this. After this, we have a seconds pendulum. What do you mean by seconds pendulum? Seconds pendulum, whose time period will be 2 seconds. So what is a seconds pendulum? Whose time period will be 2 seconds. That is called like a seconds pendulum. Nothing is there. The time period of oscillation, that pendulum is so designed, the length is so designed that it will take 2 seconds to complete one oscillation. That is called like a seconds pendulum. A seconds pendulum is used means indirectly we know the length. And the numericals, these are the ways in which you should have the information. Okay, no, even the SHM equations will be written of this kind. You have to be careful. If it is released from here, we'll write minus cos minus all this one, negative angular displacement. Okay, after this, we'll take the conditions. If the pendulum is oscillating such that if you consider the effect of medium surrounding it, let the density of pendulum be rho, let the density of surrounding medium be rho, that one, let L be this one. So previously I considered the effect of surrounding medium. Now let me consider the effect of surrounding medium, or you better say it's in liquid. If pendulum is immersed in liquid or in a fluid whose density is rho, so what about the time period of oscillations? So then we'll proceed in this way. The weight mg will act. There's a tension and there's a buoyant force. There's a theta. Then the torque equal to torque about point of suspension. This should be equal to mg L sine theta clockwise, fb L sine theta anti-clockwise, and this should be equal to I naught alpha. Why I naught alpha? The angular displacement is like this, whereas the torque is in this direction. That should be equal to mgl moment of inertia ml square, that of the bob. Mg will become density of the bob, sigma vg. L sin theta. Buoyant force will be rho vg L sin theta, negative sign. Alpha is equal to, now this m also I should replace, no? M will be sigma v. So if you take all this one, L sin theta also common, sigma v, okay, g also will be minus 1 plus rho by sigma g by L sin theta. I'll do one thing. It'll better like it. This will be the expression for this one. So for 1 minus rho by sigma g by L theta, comparing this with if density of surrounding medium negligible, then this will become very small quantity. It will become L by G. Usually we consider, if we don't consider the effect of air, then this will become negligible. Then 2 pi L by G, like previous one. If you consider the effect of surrounding medium also, then the density has to be introduced here. I think you have to remember in this way. Very crucial in exams, you can't derive, it should be a formula. Okay, fine. There's a one formula which if you remember better, no, it'll be much easier. What is rho? Rho is the density of liquid. Sigma is density of bomb. This is the effect of medium. We'll take the accelerating one. If there's a trolley, initially let it be at rest, and we have let the trolley accelerate, then we'll see the conditions. So initially the bob, the trolley is at rest, and the bob will oscillate. So what about the oscillation? What is the state of trolley? Trolley is at rest. Now let it get accelerated. So when it get accelerated, what is the time period? When it is at rest, what is the time period? Then when it is at rest, what is the time period of the bob is given by 2 pi under root of L by G. when it gets accelerated, you should get the mean position. Now the mean position will be this one. No? This will be mean position. Okay, now this is not the mean position. This is not mean position. It will oscillate about this particular point. Then I'm just going for some. This will be pseudo force MA. In the person sitting in the trolley will do this problem now. This mg will act, and the string will be tension in the string at equilibrium. And we know the string will make an angle theta. Then we have a formula T equal to 2 pi L L by G. This I will ask you to rewrite. Already we have written, no? This. Can I adjust ML? Here what happen? I'll go for G effective. So instead of this, let me write T. G effective. M G effective should be written. This is some generalized formula I'm trying to arrive. Mg effective, or this will become ml by tension in the string at equilibrium position. Otherwise, what we should do, we should displace this bar from this position, then we should calculate the torque due to MA and MG. This would be a very lengthier approach. We have just converted this into some sort of like a formula. If the point of suspension accelerates, bring G effective. Or this other alternative approach which we should have. Okay, now can we calculate tension in the string at equilibrium? This will be much easier. Te sine theta squaring and adding is equal to m. So what is the tension in the string at equilibrium? So what is this Te? Tension in the string at equilibrium. This will calculate in the time period. What is the formula? ml by Te. What is the tension in the string at equilibrium? G square plus A square. The point of suspension accelerates, we do write in this way. Okay. You know how to calculate with a pseudo force what is the string makes an angle theta, and you know how to calculate tension in the string at equilibrium. Then directly substitute here, or else you know how to interact with the G effective, how to calculate the G effective, substitute G effective here. Either way, so I do prefer to use this particular method because this is what advisable. We are very good in laws of motion, so we can take help of that particular knowledge here and we'll find out the tension of the string at equilibrium or at mean position. Tension of the string at equilibrium or mean position. Mean position with bob at rest. This is the condition, not when oscillating. When oscillating again, Te minus, it will have m omega square r. Okay, agreed. Okay, now we'll take some other different cases. Suppose this is a pendulum. It's in equilibrium under action of forces, where F1, F2 are some external forces, and the action of this is in equilibrium. Now I am asking you to calculate the time period of oscillation. So it's going to oscillate like this. It will swing here, here. These forces will be continuously acting vertically up. So what are F1, F2? F1, F2 are external forces acting on the bob in the shown direction at all times. Find time period of oscillations of the bob. How do we manage this? Hope everyone getting some picture, no? Some idea. This is what like it will make some angle theta. Theta, let me just define it here. So again, we should calculate the tension of the string at equilibrium. There will be some tension where the string makes an angle, certain angle with vertical at equilibrium position under action of these forces. So what we should do, just calculate the tension of the string at equilibrium and substitute in that formula. So we'll proceed in this way. Te Te cos theta plus F2 minus mg0. Te sin theta minus Fn 0. Squaring and adding, T is equal to then time period of oscillations is given by ml by Te. This will be more easiest approach than any other thing. Okay. What is this? This particular position is equilibrium position. Bob is in. Hope everyone getting some picture. Accelerating or this, we can use this particular following method. Let's take the Let me take two strings. I'll suspend them. This is some reference. Can be asked in exam. Here is a bob. This is a bob. We have to find out the time period of oscillation. So a particle, let me describe the question. A particle is suspended by two ideal string as shown. Now the bob is given a small displacement perpendicular to the plane of triangle formed find the time period of oscillations. Okay, earlier we had one string, now two strings are there. Now we'll go back to the original thing. This is something very, so many things are there here. I should really, what is the time period we got? L and G. So what is L? How you measure? L you measure like this. Huh? Then how G is acting? The weight mg. So G is measured here. So in the formula, all of you, here is what? What is L? Length of the pendulum. Length of the pendulum. What is G? G is the, see like here how G will act? G will act vertically down. Look at here. So this will be how much? G cos theta, G sin theta. What do we substitute in this time period expression for time period of pendulum? The effective G that is acting on the bob, which will be directed along the string. So here also G cos theta is acting. No, somewhere at mean position. You see, this is the mean position. At mean position, what is the effective G? That is what is being substituted here. And how do this effective G is measured? Which is directed along the length of the string. Something here. Oh, it's just observation. For our convenient, we are just thinking in this way. So in the expression for time period of pendulum, so at mean position, the effective G should be substituted with bob at rest. And how do this G will be directed along the string? Come for this. That's what we are doing here also. Now, what about the G? G will be acting here. This effective G will be, which will be directed along the string. This G effective will be along the string. Okay? That's what we have substituted again. Now, then come for this. Here also the same thing. Let me, I think this was the question we were here. Now, how the G will act? G will act in this direction. This is the length which we are supposed to calculate. What is our time period of pendulum? T equal 2 pi under root of y by G. That y has to be calculated. Sir, why you are taking the y only? Because how the pendulum will oscillate not in this direction. Perpendicular to the plane. Perpendicular to plane here. Perpendicular to screen, it will be oscillating. I think I'm unable to show the 3D diagram here. Will not be like this, sir. Will not be like this. Perpendicular to plane. Hope every time perpendicular to plane of the diagram, plane of the screen, it will be vibrating. Carry on now. So I think somehow that calculation of y is something very important. No? How to get this one? So let me call this is x2, this x1. Applying the Pythagoras theorem. Three, 3, this will be how much? 9 into 18L square. Keep it here. We need, and the other side, x2 plus x1 length we know equal to 7L. So y should be eliminated. So I'll take the difference of these two. This will be should be equal to 18L square minus x1 square. 25 minus 18. 7L square is equal to x2 minus x1, x2 plus x1. x2 plus x1 is 7L. And we know other equation, adding up these two. Okay, then can we calculate y? I'll substitute in any one. 18L square. x1 square is 9L square plus y square. 3L. Okay, then the time period of oscillations will be 2 pi y by g. So possibility of asking such questions, especially mains for advanced objective. What is the basic idea? The effective length of the pendulum which is directed along the G is what should be taken. Either way. Because we know now the G will be act here. So the length of pendulum. Is it pendulum suspended here? No. This will become effective length. So where Y will become now effective length of pendulum. Let me give other condition. Okay, this is the alpha. There's a beta. There's a wall. Huh? I think it'll be much easier for you. There's a wall, elastic wall. We have to find out the time period of pendulum for alpha greater than beta, for alpha less than beta. Find the time period of oscillations of pendulum for first case alpha greater than beta, or beta less than alpha, beta greater than alpha. And if alpha greater than beta, what does it mean? Suppose alpha 30 degrees, beta 10 degrees. I think it will not go and collide with the wall, no? General, directly take help of the basic diagram. If alpha, so the pendulum will be oscillating so here you can check it. This is alpha, this is beta, this will be beta. So no question of the bob going and colliding with the wall. So what is the time period of pendulum? In this case, it will be 2 pi under root of L by G. So what is the basic idea? The bob will not collide with the wall. So no question of like a time period of oscillation will be 2 pi under root of L by G. This is the first case. Second case will go for it. If alpha less than beta, I'll make it this. We'll try to wind up everything here. Second case, alpha less than beta. What is alpha less than beta? How things will be? Alpha less than beta. In fact, here you can see this. So like we are not understanding that beta. Can you show us beta? So here the bob, I will, of course the bob will not go there, but if it can oscillate, would, if there were no wall, no, it could have gone to till here. This is the meaning of that beta. So I think the wall will not permit for the bob to go on the other side. So it'll go, come, will collide and will rebound, no? So here the bob like this, we should take it out. So it will come and collide. So just I'll show that angle that will be sufficient. The beta is greater than alpha is what that angle is what I'll try to show it. Now we'll take the positions 1, this is 2, this is 3. Time taken to move from 1 to 2 will be the 1/4 of time period of oscillation. So what is the time taken to move from 1 to 2? Should be 1/4 of this one. How to calculate time taken for the bob to move from 2 to 3? Yeah, yeah. This time is what needed. Time taken to move from 1 to 2 is will be 1/4 of the time period. 1/4 of T1. Time taken to move from 2 to 3 has to be calculated. What is the maximum, what is the amplitude of oscillation of this bob? Will be beta, no? So then we'll take this equation, theta equal to beta sine omega t. Time taken for the angular displacement to become alpha. Is it okay? Then what is omega? Omega should be equal to G by L. Time taken for the angular displacement to become alpha is equal to beta. Agreed. So this is a time taken to move from 2 to 3. So alpha by beta sine inverse of overall what is the time taken? Time taken for the oscillation should be equal to T dash should be equal to 2 times of T12 plus 2 times of T23. This should be equal to 2 T1 by 4 plus 2 T23. T23 is root of L by G. T1 is what? 2 pi. So this will become pi root of L by G plus 2 root of L by G. This is a time period of oscillation for second case. Just simple mathematics. Okay, fine, sir. We didn't understood this. What actually this is like. Time taken for the angular displacement to become from, because this is the mean portion we'll measure. Beta will become amplitude of oscillation. You can see this one. This alpha is. What is the time taken by the pendulum for its amplitude to become from 0 to alpha? The angular displacement to become alpha. Here the bob is having 0 angular displacement. Now as it ascends, angular displacement will become alpha. So what is the time taken for it? Okay, this we will take the next condition. We'll bring some nail. Okay, this is some nail which is at a distance 3L by 4. Then we'll release a bob of length L So this particular point is a nail. Whatever the time period of oscillation. So where a nail will be at a distance 3L/4 from the point of suspension. Find the time period of oscillations of the pendulum if a nail is fixed at a depth or at a distance 3L/4 below the point of suspension. So what what is this, Bob? Okay, here it will come like this, no problem. But after when it comes here, it will start swinging about this one. Are you getting no? So when it moves from 1 to 2, so 1 to 2, it will be path like this. For 2 to 3, the length of the pendulum will become L/4. So not understanding. Okay, it will be like this. Will come like this. After that, will be oscillating. Are you getting now? So here it will oscillate like this here. The length of the pendulum will be L/4 because now nail will become point of suspension. For path 1 to O will become point of suspension. So we'll write condition this O for path 1 2 and 2 1. Point O will be Bob oscillates. Bob oscillates about O. Next again for path 2 3 and 3 2. The Bob oscillates about nail P. I'll write it. So what is the total time period? T dash is equal to pi Lg, or it will be like this, 2 times of T12, 2 times of T23. What is the T12? 1/4 of the time period. So 2 pi. What is T2? So this will be 2 pi. Length is how much? Will be L/4. Why 1/4? Because this time taken for the bob to move from 1 to 2 will become 1/4 of the total oscillation. 2 to 3 will be 1/4 of the total oscillation if the length of pendulum is L/4. Small idea based, definitely in advance, they will be interested to test students only of this one rather than something forcing mathematics on you. Small ideas. And very important, you check the previous advanced paper also. we'll take some other questions. A simple pendulum of bob of mass m is oscillating with an angular amplitude alpha naught in radians. Find the maximum tension in the string. Theta naught, I'll write it. That's better. Carry on. Find the maximum tension in the string. I'm helping you with the diagram. This was the maximum amplitude, what is giving. Huh? So where the tension, when it is oscillating, find the maximum tension in the string during the oscillation. I'll complete this question. Okay, this tension here, this mg, here the tension, this will be maximum, I feel. Is asking this maximum tension. So it will descend some height h. So here, what is the equation? First we'll calculate that mv square, that one. Decrease in gravitational potential g. So mv square L 2g 1 minus cos theta naught. Then T max minus mg. Say centripetal force, the required centripetal at mean portion will be T max minus mg should be equal to mv square by L. mv square by L is what? 2g 1 m will be here. 2 mg 1 minus cos theta naught. T max equal to 3 mg minus 2 mg cos theta naught. Cos theta naught, I can expand it as 1 minus theta naught square by 2. Here all the terms will neglect it. So this will become 3 mg minus 2 mg. That during oscillations is very important. This was the main question. Now you can ask questions like what you did something. You did some. How do I come to know I should do such approximations? Because what is a basic pendulum itself? When we say pendulum, the angular displacement what we give will be of few radians. You need not to mention it that theta naught given small angular displacement is oscillating with an small angular amplitude. It would have been very specific, but he didn't mention because we know that the simple pendulum, what we do in the lab, will be for small angular displacement only. I think keeping the lab conditions in the mind, he might have stressed here. Actually, with small angular amplitude theta naught. Okay, fine. Everyone will do like this, but he didn't mention. But what all we do in the lab, simple pendulum, it is for small angular displacement only. Then only the formula is applicable. I think a very strange way of troubling students. I just picked up the way, see, everyone knows all the concept, but the way you ask, interpretation of that matters a lot in it. Two pendulums, X and Y, of time periods, 4 seconds and 4.2 seconds, are made to, I'll fill up like this, are made to vibrate simultaneously. They are initially in same phase. After how many vibrations of X, they will be in same phase again. They will be, carry on now. We know all the ideas, huh? Time period of pendulum 2 pi L by G. But what he has asked question, try to, this is the pendulums. The time period of two pendulums are given, they release simultaneously with the same phase, they release from one position. After what time again they'll be in same phase. How many vibrations? What do you mean by how many vibrations? How many cycles X will complete? What is the time period of this one? 4 seconds. Just for our understanding, actually both are suspended at same point because they're having different time period. Huh? This will be X, this will be Y. They'll start oscillating. But look at the time period of oscillation. When X takes 4 seconds, what about Y? Y, when X completes one vibration, One vibration means one cycle. What about y? Y would have not completed. Somewhere maybe just about to complete. Both are given same angular displacement. I think we are not talking. Both are initially released from same position. So will be. But how much of time? This will take 4 seconds to complete one oscillation. By the time X completes one oscillation, what about Y? Y would have not completed. I think this is the basic condition. How to deal with such problems? Again, they'll be in same phase means what should be the initially they're having zero phase, no? Initially they're having zero phase. Then again they'll be in same phase means what should be that one? That should be equal to 2 pi radian. So we will go for like this, theta 1. The phase angle cannot be zero. Again they'll be in same phase means it should become equal to 2 pi. So what is theta 1? Theta 1 should be equal to, so the time will be 2 pi. So this T1 will be 4. How much it will be? 116.8 by 0.2. 81 seconds. This is the, but how many vibrations is asking? After 81 seconds, both will be in same phase. But how many vibrations of X? The X for one vibration, the X will take 4 seconds. For 81 seconds, how many vibrations? For 4 seconds, for X, 4 seconds it will take for one vibration. For 81 seconds, how many vibrations? So N should be equal to time taken, no? Oh, 84, huh? Just check 168 by 2, 84. So this will become 84 by 4. How much it will be? 21, huh? Yeah. After 21 vibrations, again, after 21 vibrations of X, again, they'll be in same phase. Why we should think in this way? See, initially, what was the phase? Zero. After some time, the phase angle should become 2 pi, no? So why you can't write 4 pi? Yes, we can write 4 pi, we can write 6 pi. But what was the question? After how many vibrations of X, they'll be in same phase. After how many vibrations? If you write 4 pi, yes, 6 pi, it will be. After is used. If more than one option comes, then you have to go for again 4 pi, 6 pi also. Since single option, okay, we are going for the least value. Any doubt you can clarify? Anybody having doubt, you can clarify. Okay, we'll take some compound pendulum one. There's about a physical pendulum or rigid body oscillations. I want it. Let me begin with the rod. You can use mathematics, no problem, sister. This is the rod of mass m having a length L. I'll displace it. I'll suspend about point P. This is the point of suspension. This is the center of mass. So now when I suspend it, the center of mass will shift up. So this will set up a torque. This is a rod, rigid rod. Okay, now what is the torque? Torque about point P should be equal to mg L by 2 sine theta. This should be equal to Ip into alpha. How the torque will act in this sense. So therefore minus will bring it. So mg L by 2 sine theta. What is moment of inertia of this? So this will become for small angular displacement. Time period is given by 2 pi 2L by 3g. Directly we are bringing it. So instead of something simplifying, let's have some general formula. Huh? Alpha is equal to what is L by 2? L by 2 is a distance PC. So this I'll start from here. IP into alpha mg. This distance is what PC sine theta. So where alpha is equal to mg PC by IP for small angular displacement. So what is that PC? PC is the distance of separation between the center of mass and point P. And what is IP? Moment of inertia of that rigid body about the point of suspension P. This will rather than this will become a generalized formula. This is applicable for any rigid body now. This will be applicable for any rigid body. Means like a point of suspension will vary it. As proportionally the distance PC will change, calculate the moment of inertia and work out. Okay, this will do for the best thing is we'll start with the ring, for ring or some disc. It is suspended above this point. This is a point of suspension. This is X, this is Y. So I'll display this in the XY plane. If it oscillates about Z axis, two things are there. It can oscillate about X or Z axis here. Find the time period of oscillations of the disk about X, about Z axis. We'll do the both the things. Let's see how that formula will help us find. Find the time period of oscillations of the disk. We know what is the separation between P and point of suspension and the center of mass. It is equal to R, that we know. Moment of inertia about that particular thing we should calculate here. So time period about first Z axis will go for it. That should be equal to IPZ mg. The distance is what? Pz. Let's substitute all the things. 2 pi. Moment of inertia about Z axis, that should be equal to IC plus mr square mg into R. What is IC mr square by 2? They are by 2g. What about the x-axis? X-axis should be equal to 2 pi. Moment of inertia of the disk. Moment of inertia about x-axis. About any diameter. ICX plus mr square by mg into r. 2 pi. What is ICX? Moment of inertia of the disk about diameter. This one. Should be equal to mr square by 4 plus m into this one. About any diameter plus mr square. This will be 5 r by 4g. I think girls will be wearing some earrings related to that. The ring can oscillate. The ring can oscillate perpendicular to plane of paper. So I think you should be very particular about the uh, axis of rotation. Point of suspension, okay. In which plane it is oscillating, see that answer matters here. Time period of about z axis. So what about this time period about? There's a disk, no? There's a disk, no? If it were ring, okay, substitute the moment of inertia of the ring. What I'm discussing is for the disk here. If he calls ring, no, then moment of inertia of the ring you bring into the picture. Now connecting rigid bodies. This is We have, if we have a bob, and also I'll suspend a bob here. There's a thin rod. What about time period of oscillations? This will be very troublesome, students, for especially for students. No, the string is having mass. Better say, it has become now thin rod. What about time period of oscillation? Again, the method will be same. Just stick on to the weight of this will act mg, weight of the rod, thin rod, and the weight of the bob. As I said, it's a bob, so moment of inertia, this will become like a particle. Bob or particle both are same. This like this. So then what is the expression? M2G L sine theta plus M1G L by 2 sine theta is equal to point of suspension I naught alpha. So this will be M2G L theta L by 2 theta. Moment of inertia, what shall I write? That of the rod will be M1 L square by 3. M1, M2, sorry. This will become M2 plus M1 by 2 G by this will be one L will be here. For small angular displacement, so this will become T equal to 2 pi M2 plus M1 by 3. Now, very troublesome things, huh? You have to be very careful, huh? Small ideas, huh? And now, instead of that bob, if it is a circular disc, what you do? Circular disc of radius r. I'm saying it will be a circular disc. This is M1, length L. Let me write clearly. This is a length. This is having radius r. This is M2. This is a disc now. Thin rod. Yeah, carry on now. So again, the method will be same. The weight M1G. I'll give small angular displacement, and the weight of this will act here. So the torque setup will be M2G L plus R sine theta M1G plus L by 2 sine theta. That should be equal to moment of inertia of rod M1 L square by 3 plus What to do here? Moment of inertia. M2 r square by 2 plus M2 L plus R whole square, all set into alpha. Very moment of inertia of this whole system. That of the rod, how much? M1 L square by 3. That of the disk, first about its center of mass, no? M2 R square by 2 plus M2 into this distance is how much? L plus this radius R. If we mention if we mention that L very much greater than, or if we mention something like this, in that case what you should do here, you can take it R out. R negligible, here R negligible. If you put a condition, then it will become similar to, so this quantity you has to be considered here. Usually when this means, again R will not be, so this will be rigid body oscillations. Solve for alpha, will get the required answer, will be very lengthy. Alpha will be, I don't think so anything can be taken, just only sine theta will come outside. In exams, they may trouble you with some data of this kind. Just be alert. G alone I'll bring outside, because that's what will be. I I think it's all about calculation of moment of inertia, no? The rigid body oscillations. Anybody having doubt, you can clarify. What happens if the pendulum is suspended about center of mass itself? What conditions will arise? If the pendulum is suspended about center of mass itself, the compound pendulum, this one, I'm suspending it about center of mass. Then, what will be the time period of oscillations? Where is the point of suspension? Exactly lies at the center of mass. Yeah, this will be. Now, what is the formula? Basic formula: T equal to 2 pi moment of inertia into mg into Pc. The point P and C both are at same point. So what is Pc? Pc will become 0, no, here. So time period will become infinity. What do you mean by that infinity? In whichever position you keep it, it will retain that particular position. It will remain there only, it will not return back. This is some sort of like a, shall we say, neutral equilibrium. So here the center of mass, center of gravity. If the pendulum, if a rigid body is suspended about its center of gravity, then it will be in neutral equilibrium. What is C? C will become center of gravity. If the point of suspension is about center of gravity, then it's going to have the infinite time period. Infinite time period means in whichever position you keep it, it will retain that particular position. Means will not oscillate. What do you mean by infinite? Uh, Here, rigid body will not oscillate. There's a basic idea. Not only this, you can pick up any other shaped object. Here I just discussed only for this one. Any other shaped object, you can consider this one. Now, sir, if rigid body is suspended by strings, what you do? I think good question, no? Can be if the rigid body is if the rod is suspended by a string, by a strings or a string, what conditions will arise? Definitely, I think there's a very there's a rod. Hmm? Okay, there's two strings are there, so let this be length. These are the strings, and this is the length of the rod. We'll do one thing, L2, L1. This having a mass, and the gravity will act here. What is the time period of oscillations of it? In exact plane, if I define this is find the time period of oscillations of the rod in exact plane means it will be twisting. Find the definitely string is there and there's a rod. I think first we have to how do it will oscillate. Just we'll take some reference diagram. I'll try to explain through some. There's a position of the rod will be swinging here. This way. Hope everyone is able to understand. So let me give another diagram. If it is like this, small angular displacement will be given. Rod will not oscillate in XY plane, it will oscillate in XZ plane. I don't have any other diagrams other than this. Please, you should able to imagine after this. Okay, sir, like still we are not able to. In XZ plane, the rod will rotate. A, B, C, D, let me take here. I will try to give, okay, this is the point C. This is A. This is the beta. So slightly, when it twisted, when the rod had been rotated in XZ plane, this string will make in some angle. This particular string will make some angle. Okay, let that angle be beta. This is the C. Let this distance be x, and this length is L2. And the tension will act here in this direction. Let me call this T naught something. Then what about the, so like still we are not able to understand. So let me take the, this will be the position, no? This will be the rod. Regarding tension, let me show it. This is the point 2. This is the theta. This will be L1 by 2. Component of tension, how it will act? One component of tension will act here. T naught sine beta will act here. And this is alpha. Say the tension will be set up here, no? T naught cos beta will act vertical. T naught sine beta will act in this direction. So this will set up a rhetoric tone. Slight given angular displacement. So what is this T naught? Initially T naught. T naught is tension. I'll write F. Some of you are getting with the time period. I'll write F. F is what? Tension. I think this will be a better idea. So what is F? 2F should be equal to mg. Let's write the equations. F equal to mg by 2. How to write the torque equations? First, shall we equate some things here? Looking at this one, this distance should be equal to x. Any relation between theta and beta. So from first equation, x equal to sine beta x by L2, beta very small. Then from this triangle, sine theta equal to x by L1 by 2. Theta very small, sine theta. I'll bring all this. Theta very small, it will become 2x by L1. I think now we'll get the relationship between this one. What is x? X equal to L2 beta. So this will become 2L1, L2 beta. All this L1 theta equal to L1 theta by 2 Either way. Okay, this is one primary equation which I needed. Let's write the torque equation. We'll set up the restoring torque, this particular force only. And that particular force will act at both the ends of the rod, component of tension, F sine beta, here also F sine beta. This is the top viewer. These are side view. Let's write the torque equation. What about the torque equation? Torque equation will be F sine beta into, this will be L1 by 2 cos theta, 2 times, because both the forces here, no, F sine beta, here also F sine beta, about O. This should be equal to moment of inertia of the rod about O into alpha. What is F? F should be equal to mg by, let me write one more equation, no problem. This will become F sine beta L1 cos theta equal to ml square ml1 square by 2l into alpha. What to do beta? This I'll replace it. What is F? F should be equal to mg sine beta. Beta will be L1 theta by 2L2 into L1 cos theta equal to m L1 square by 12 into alpha. L1 square get eliminated. So this all together alpha will be theta very small, cos theta equal to 1. Anybody? 3g by 2L2. Only 3g by L2 into theta. Then time period of oscillations will be this replacement we have done. Sine beta will become beta. I'll do one thing. We'll write this is theta. Beta very small. If a rod and strings are there, we have to be careful. The same conditions will come. I think making observation of the system in different planes matters a lot. I'll bringing the total. This will be our answer. The rod will rotate in the XZ plane. We are discussing. It cannot rotate in XY plane. If it rotates in XY plane, the strings will become loose. Here why we took it in this way is like when you give a small twist, the tension will change. In fact, but the change will be negligible here because of two strings here. I'll write that condition. F is tension the string. The tension in the string almost remains constant as the rod oscillates. It is not oscillating in some sort of like a not like a pendulum. You can see that also. Vertical force all the time has to remain constant because the see how the weight mg will act. No? So who should balance that mg all the time? It is not swinging perpendicular to plane of paper. It is in exact plane. It is rotating. So the net vertical force should be equal to mg, no, and that net vertical force should be equal to tension only. So that the angles are very small. So small change in tension will come. Will neglect it. I think now the rod string. So we are. I think we have just made it very things like only string we brought bob, then rigid body oscillation, then your string and the rod comes. So in which plane it is oscillating based on that. The real the rod cannot oscillate in XY plane. Some of you must know this one. Huh? It cannot oscillate. Like if you set it oscillate as it will come. Provided what pen both the strings should become parallel. I think this question is there in SU or my if you want to do it once. It can oscillate here, provided both the strings should remain parallel. Okay, we'll end up the class. Okay, kids, like today I just discussed about the simple pendulum and the compound pendulum. Some different types of numericals is what I took it. You check the J mains. He has given highest priority for the pendulums. Even the JE advanced also you can take it. Some mixed concepts are there, no doubt. But when it comes the mains or the advanced, what is the priority topic here? So definitely you can say that it's a pendulum, physical pendulum or simple pendulum. Anything related questions on this will be stressed a lot. Highest priority I'm telling. It's not about the weekend exam. Weekend exam is what I should ask the total SHM part test that one. I'm just talking about the final exam when you go for mains or advanced. The priority topic will be the pendulums. So try to think or put some effort. So any question comes will be in a better position. Then mains definitely can say there's highest priority. Regarding pendulums, have a criteria and go to the exam. Little bit easier. Next comes kinematics of SHM. Then comes the this one damped and forced oscillations. So mains preparation I think should be very crystal clear. You must know the small topics like pendulum, kinematics of SHM, damped and forced oscillation. You need not to bother about spring block system, all XYZ. They're relevant and you can manage also anything if they ask you. Advanced you have to just gather the different types of numerical, but the priority again should be this topic. Okay, fine. Huh? So try to revise all the things. Okay, tomorrow we'll go for some mixed concept. Or I think almost 2 days we have spent it. Tomorrow let me go for SHM with the different types of systems, like a SHM with viscosity, SHM with the surface tension, SHM in electrostat. Because almost all the syllabus got over in all the topics. How that SHM's related questions will be coming. It'll be like a good revision of the other topics also. Okay, thank you all of you. Take care. Bye.